Pentek provides leading-edge board and system-level solutions for the most demanding requirements in data acquisition, digital signal processing, and software radio applications through excellence and innovation.
We're going to take a closer look inside the Pentek Model 78640, a 3.6 GHz 12-bit A to D board. This board is a PCI Express form factor, but it's also available in XMC, 3U and 6U compact PCI, and VPX. The Virtex-6 FPGA connects all the devices on the board to form a complete data acquisition engine. The Texas Instruments ADC 12D1800 can be used as a single-channel 3.6 GHz A to D or as two 1.8 GHz 12-bit A to Ds. Clocking, timing, gating, triggering, and multi-board synchronization are handled by the timing generator. 2 GB of fast DDR3 SD-RAM capture A to D data in real time. A fast BY8 Gen 2 PCI Express interface connects this board to your system at up to 4 GB per second. Secondary LVDS and gigabit serial ports offer system expansion. Inside the FPGA, we have two identical data acquisition engines supporting synchronous triggering and gating for the A to D data. A metadata generator timestamps and identifies blocks of captured data. Data can be captured at the full sample rate into DDR3 onboard SRAMs or sent out across the PCIe interface by a linked list DMA engine to system memory. The acquisition engine is fast enough to capture real-time signal blocks at the full clock rate in the 2 GB SD-RAMs. Then the data can be played out through the PCI Express interface to system memory at up to 4 GB per second. This is ideal for acquiring very fast radar pulses. Signal quality is difficult to achieve in a high-density FPGA software radio board with so much digital circuitry. Advanced shielding, isolation, and filtering in the 78640 maintains the 68 dVc spurious-free dynamic range for a 500 MHz input signal sampled at 3.6 GHz. This is the same spec as the TI device. In this synchronous 8-channel 1.6 GHz 12-bit A to D converter system, we're using four 78640s. A 7892 high-frequency timing generator board is used to generate synchronous clocking and triggering of all four modules. Four microsync cables connect each 78640 to the 7892 clock generator. A 10 MHz reference clock phase locks the VCXO on the 7892. For more than four boards, we offer the 9192 1U chassis for systems with up to 12 boards. All Cobalt boards feature health monitoring resources including 11 onboard temperature sensors for strategic components and 6 onboard voltmeters to make sure the many power supplies are within spec. This simplifies systems diagnostics to verify operation at power-up, and alarm set points can generate an interrupt to the CPU during runtime. Many applications can be satisfied with the built-in IP functions where no FPGA IP development is required. But for many applications, the Cobalt module is an ideal platform for custom processing IP development and deployment. Pentek has developed the GateFlow FPGA design kit just for this purpose. Designed to work with the Xilinx ISE design suite, GateFlow supplies all of the built-in functions as IP modules with VHDL source code and test benches. GateFlow creates a user application container where all interface signals to the modules are fully defined and documented. The factory-installed acquisition modules are created in this space. Partitioned in this way, your custom IP can reuse many of the Pentek IP modules or replace some or all of the factory-installed functions as your application requires. Pentek's ReadyFlow board support package provides the software development component to the Cobalt family. Delivered as high-level C-callable libraries, ReadyFlow contains all the routines for board configuration and operation. Available for Windows, Linux, and VxWorks operating systems, ReadyFlow libraries are fully documented with C source code provided. ReadyFlow requires no runtime license, and a single seat can be used for multiple projects. The ReadyFlow BSP includes many applications examples that can be used as tutorials or as the foundation for your application. ReadyFlow also includes pre-compiled examples that can be started through a command line interface. Simply enter the command with parameters for which channels to enable, the number of data sets to acquire, and a destination for the data, and the board will begin operating. Data can be sent to a file, to another application, or to the included ReadyFlow signal analyzer, where it can be displayed and measured both in time and frequency domains. With the command line interface and the signal analyzer, you can be up and running within minutes of opening the box and without writing any code. Pentek's customers are using the 78640 both for wideband communications and for radar. Often, customers want to capture communication signal bandwidths up to 1 GHz or more, and this is the board for them. The built-in data acquisition engine easily captures radar pulses using external hardware triggers to form precise range gates and complex acquisition sequences. Synchronization across multiple boards supports phase-coherent operation for multi-element antenna arrays.
Contact Pentek for price and delivery and for application design ideas.